Hat, please. All right, exponential word problems. We really probably should be covering some word problems that deal with logarithms, but there aren't that many out there that have formulas that are similar enough that we could cover that. So as we go through these have formulas that are very standard. You may recognize a lot of this lesson today because it is taught in Math 1, but some of it's not. And this first example might not be taught in Math 1. Percent over time. When something changes over time and you want to know what percent is left or what percent it went up to, then you have to have a formula that's just based on percent. And that formula would be 1 plus or minus r to the t power, or sometimes they'll put an x up there. It varies a little bit on which letter's up there. The plus or minus is there because they want you to be able to make it grow or decay, increase or decrease. So the town of Danbury is losing 15%. What does that tell me right away? Yeah, it tells me the ratio to put in there as well as it's losing. Right. 1 minus. Definitely losing. Everybody agree? You also have to move the decimal over 2 places to drop the percent sign off, because in math you can't put a percent in any formula. You always have to move the decimal over so the percent sign will drop off. And then it says what percent will be left in 10 years. So our power is 10. Now this gives me a decimal that represents the percent. So that's just 0.85. I mean, honestly, we can tell what that is by subtracting it from 1 because it's what percent out of 100. 100% minus 15% is 85% left. So it would be easier to just do that subtraction in your head away from 100 to figure out that decimal, so you could just type that in. But if not, you could type that in. So 0.85 to the 10th power is going to tell me what population percentage-wise am I going to have left. Now, what does that come out to be? Does it round up to 6, 7? Okay. So I need 3 decimal places, not because that's what we've been doing, but because I have to move the decimal 2 places and still have 1 left. You see, I have to turn this back to a percent. And a percent, the standard number of decimal places on a percent is 1. So if I use 3, like we've been doing, I can move it over 2 and still have my 1 decimal place. All right, so this is a formula that helps you to calculate it, whether it's increasing or decreasing. You just do the plus or minus and out comes the answer. But you do have to turn it back to a percent. Now let's look at number 4. I'm either doing 1 or 2 off of each set. And usually I'm doing the first one off each set, but sometimes I might do another one. All right, rate of the original. When someone tells you that they're going to give you a penny today and double how many pennies they give you every day, your rate is doubling. Okay? That doesn't mean that I'm adding 2 to 1. That is your rate. Okay? There's a big difference between making a rate increase or that is your rate. So when they give you a rate, like I'm going to have something, I'm going to double it, you're going to remember 3/4 of the words you learned in your Spanish class. That type of math is the rate. Now the other thing you have to remember about this particular type of math is that it uses the formula AB to the X power, where A is your original amount, B is your rate, and X is the number of times you want to do whatever it is you're doing, halving, doubling, 3/4ing, whatever it is you're doing with your rate. So this formula I know you saw back in Math 1. A piece of notebook paper is only 0.0032 of an inch thick. Wonder what they measured that with. It's not like I can hold it up next to my ruler and see that it's that thick, right? Must have to have a special tool to measure something that thin. That would be A. With one piece of paper that's that thick, double it 25 times. Double is my rate. Because double is what I'm doing to the math. I'm doubling it. Every time I add a piece of paper, I've doubled the thickness. So if I add a piece of paper to it, now it's twice that thick. Then if I add twice that many pieces of paper, it'll quadruple it, and so on. And then it says 25 times. So we put that 25 in as our power. How tall will the stack be in the inches? Well, the problem's in inches, so it makes sense so they ask me in inches. And so I just work that out, and that'll be how many inches deep the whole pile will be if I pile on twice as much paper every time. So if I start with 1, then do 2, and add 4, and then add 8, and then add 16 pieces of paper, that'll be how thick it is. And how much is that?
A lot.
Yeah, a lot.
107, 374, 1824.
1824 would make it stay 2. 1824, yeah. And that's inches. Now, normally in a problem like this, because it asked me to leave it in inches, I'm going to. But in a problem like this, if we got a number that large and they didn't tell me to leave it in inches, I could change it to feet and see if that seems reasonable. I could change it to yards and see if that seems reasonable. I could even change it to miles to see if that seems reasonable. That might be what it would be. I mean, if you think about it. Divide that by 12. All right, divide it by 3 and turn it into yards. Yeah, that's still a huge number, isn't it? But it's not a whole mile, because a mile is 5,280 feet, which would be a 1,000. Well, no, it is a whole mile. You said 2,000, didn't you? 1,700 and something, I think, is a mile, or 600 and something. So it's over a mile deep. Exponentials grow quickly, don't they? All right, next set. Let's move to number 7. In number 7, we're talking about increase and decrease. Very important words in the problem, because that's going to tell you something about your formula. See, in that last problem, they told me double. You know, they could have told me I'd have had 100% more. Think about it. If you increase 100%, isn't 1 plus 1 2? That's what doubling is. It's an increase of 100%. All right, so this formula, percent of increase or decrease, is not finding a percent, because the question says how many cell phone subscribers. They're actually going to find how many's left if I increase or decrease by a certain percent. That formula is A1 plus or minus R. So it kind of looks like that first formula we had, to the T power, or that could be an X up there. Sometimes it's not about time, but most of the time it is. And so that's the same formula we looked at in the first set without the A on it, because without the A on it, it finds a percent. And with the A on it, it finds what you're looking for. How many? So in 1985, there were 285 cell phone subscribers in a small town of Centerville. So that sounds like how many I started with. A. Little a always stands for the original amount. After 1985, the number of subscribers increased by 75%. What's R? 0.75. And we're going to need increase, so that's going to tell me I want plus, right? And then, how much time has transpired? How many cell phones will there be in 1994? So what's T? Right, because you're going to subtract these 2 years and find out how many years have transpired to have something to put in for T, because T's how many years, not what year it is, but how many years from the beginning. And why it's like that is because there's no 0 in years. It went from 1 BC to 1 AD, there's no 0 year. So that's why you have to do that. So 285 1 plus 0.75 to the 9th power will tell me how many cell phone subscribers there will be at that time, which is definitely going to be more than 285 because it's increasing. So if you get a number less than 285, you're doing something wrong. That would be a clue. Now, how many cell phone subscribers I have, I don't think I want to write a 3 decimal place answer for that. Have you ever seen part of a cell phone subscriber? Mm-mm. So let's talk about what kind of rounding rules do we want to talk about. Because it's not always 5 or more, y'all. Okay? Like buying gallons of paint. If you need to, or rolls of wallpaper. If you need to buy some and you calculated up your square footage on the walls and it says buy 2.4, you're going to buy 3. Because you have to round it up to have enough to use. You can't buy 2, can you? And need 2.4. Does everybody see what I'm talking about? That's called the rounded up rule. Because I got to have a whole nother one to be able to make it work. Then there's another rule called the truncate rule. The truncate rule says that I have part of one and I'm just going to truncate that decimal off and throw it away and not even use the 5 or more rule at all and not make it go up. So if I was using the truncate rule on 2.4, it would stay, let me use a different number, 2.6. 2.6 we know rounds up to 3 if I use the rule, right? The 5 or more rule. It also rounds up to 3 if you're buying gallons of paint or rolls of wallpaper. But if I was using the truncate rule, 2.6 would be 2. Because I don't care about the 0.6. I can't have 0.6 of that. I have to have a whole number. And then, of course, we all know about the 5 or more rule. Well, in word problems, sometimes what you round it to is based on the truncate or the rounded up rule, not the 5 or more rule, because of what you're working with. So I started with 285. What decimal are you getting? Anybody? What's in front of it?
43,871.
Okay, let me start over. 4, 3, what? 871 point. All right, so that's what you're thinking, but this is subscribers, okay? So, in that 9th year, do I have enough here to say we definitely have 43,871? Or should I round it up because I got a 9 over here? Or should I just truncate it? Or should I just round it up because you can't have part of a person? That's what we're trying to figure out. Now, this is people. Do you have enough to make that next person? No. So 43,871 subscribers is all I can do because I don't have enough to make the next person. I only have 0.9 of a person, and that doesn't work. Now, if you were taking a multiple choice test, they wouldn't have both answers probably there rounded both ways. So it would be real clear which one it was. And they might always use the 5 or more rule, because some people do. But in real life, people don't always use the 5 or more rule because they don't want to add an extra something in to the situation. All right, new cars being purchased. Number 9. So skip over number 8 and go to number 9. A new car is purchased in 1990 for $14,000. They weren't that cheap then, so this must be a used car. And the value of the car depreciated 12% per year. What's the value of the car in 2000? So again, we have $14,000 is what we started with. Is it plus or minus? Well, I'll try to make a 1. Is it plus or minus? Right, depreciates means minus. Minus what? 0.12. Now, it was 1990, and now we're going to the year 2000. How many years you had your car? 10 years. So now, we'll figure out what's the value of our car so we can figure out kind of, we're getting ready to get a new one. We want to know what to sell it at. I know it's 3,000 and something. 3899 point what? Well, what's it say? 4? Okay, let's talk about that. This, it says 3? 3, huh?
It's .013664. I didn't know.
Okay, 3664. Okay, we'll look at all that. All right, so that's what you got. Look at this digit. It's either a penny or 2 pennies. Now, in money problems, they always pretty much use the 5 or more rule. But like, let's go to Food Line for a minute. And let's say we're going to buy something 3 for $1. How much do they charge you if you buy 1?
Right 50 cents.
Okay. 3 goes in 100, 33 and 1/3. Can you have a third of a penny? No, so they round it up automatically to 34 cents and charge you 34 for 1. Because they're going to get their part of a penny. That's why you might see sometimes you have something that doesn't seem quite right if you just buy 1. But if you'd bought 3, you'd have paid $1. So in these problems with money, they always use the 5 or more rule to round it. So that makes this stay a penny because of 3 sitting next to it. So each kind of problem might be a little different depending on if it's going to be a whole number, can it be a decimal, that type of thing. And money always gets rounded up to the next penny because you're going to have to pay an extra penny if you was going to the store. Now this, you're going to sell your car for this. So, you know, you might decide, oh, I want to charge $4,000 for it. I want to make a little more than that. Somebody might pay that for a used car. It's 10 years old if it's in good shape. Who knows? All right, let's go to half-life. And this question, I added something to it that is not on your packet because I realized I must have accidentally deleted part of it when I was cutting and pasting. It's supposed to say from the body every 2 hours. And that's not in your packet.
They do science.
Wow, we study science and math. Can't do science without it. Yeah.
I just remember I hated Williams.
Well, you know, in math class, maybe it's a little different. I don't know. They gave you the formula in this one, and sometimes they do give you the formula partially filled in. Let's talk about what they filled in and why. So it says a half-life of the medication, that about half the time of the drug will be eliminated from your body every 2 hours. The half-life formula for ibuprofen and Advil is this. R equals M times 0.5 to the T over 2. Now, this 0.5 represents what fraction? 1/2. That's where the word half-life came from, because this means a half. This 2 under the T came from how long it takes before it halves. It takes 2 hours before you have half of the medication in your body. So that's where that 2 came from. Now, let's talk about part A. Now, this formula is already filled in. Some of the formulas won't be, so we'll go over one that you have to fill in yourself also. 200 milligram dosage of Advil was given at 1 o'clock. How much milligrams will you have at 6 o'clock? So step 1. How much did you have when you started? Because that's M. 200. The initial dose we took was 200. How long is it between your dose and the time that you want to know how much is left? How long is it between here? 5 hours. So that'll be 5 divided by 2. Or we could put in 2.5 if you want to go ahead and have that say 2.5. But in your notes, it'd probably be a good idea to write down where the numbers went, not put 2.5. But if I was typing in my calculator, I'd put 2.5. So 200 times 0.5 to the 2.5 power, since that's what 5 divided by 2 is, will tell me how many milligrams of medication I have left in my system 5 hours later. Why that would be important is because some medications say take it between 4 and 6 hours, right? So if you're getting fairly low on your dosage at that time, it would be time to take it again. Some dosages say take it every 12 hours. So I guess we'll see how much we've got left, because I can't read the package to tell how often am I supposed to be taking this. How much do I have left? Hmm? 35 point what? 3 decimal places. 355? We can write 3 decimal places on that because milligrams can be a decimal. So that's quite a bit left. I mean, it's not a huge amount. I started with 200, but I don't think I've run out too much yet that I wouldn't be able to, I don't know if it's time to take it yet. So our second question asks us to take the same dosage and figure out how much would be in our body after 12 hours, because we need to see, is it really that 4 to 6 hour thing, or is it a 12-hour thing? So 200 times 0.5 to the 12 divided by 2. Where am I going to type my calculator for that? Yeah, we know how to divide that in our head. So don't divide out fractions like that in your calculator. Just do them in your head and put it in, because it saves typing. So 200 times 0.5 to the 6th power (3.125 milligrams). All right. So based on what we see here after 5 hours and after 12 hours, do you think this is a 4 to 6 hour type medicine taking it, or do you think it's a 12-hour tablet? It's a 12-hour tablet. You have just enough left in your system for you to take it again after 12 hours and it start to dissolve and get into your system before you lose the rest of it. And that's what they have to do at the pharmaceutical companies to make sure that it dissolves at the right rate, which is why people shouldn't crush pills and take them, because when you crush it, it doesn't dissolve at the right rate. It dissolves immediately and gets it all in your system at once instead of slowly dissolving. But if you're one of those people who can't take pills, that would be a problem, wouldn't it? All right, number 13. We're going to look at another one, because there are different ways the information can be given to you slightly. So I want to look at 3 of these, and this doesn't have the formula given to you. So we also want to look at, this is still the A, B, X power type thought, but it's A times B to the T divided by the time to half. That's really what the formula is, because this power here is X, and that's how you calculate that X. From the previous formula we just looked at a minute ago, A, B to the X power, T over time to half is what X is. So we have phosphorus we're using to study plants and fertilizer. Well, that would be important, because if I'm going to grow a corn copper, I need to know how often to put the fertilizer on. I need to know how it dissolves and goes away and gets used up. It says the half-life of the fertilizer is 14.3 days. So every 14.3 days, whatever I've spread out there, I'm only going to have half as much at the end of 14.3 days. Write the exponential decay function. So first of all, they told me it's decay, which tells me I should be having a B value that's less than 1. And they told me it's a function, which means I should use function notation, not like R equals or Y equals or X equals or anything like that. So, since this is fertilizer and phosphorus, I could use either P for phosphorus or F for fertilizer. Either one would work. I could also use A for amount, but I think one of the other two would be best, so I'll use F of T. T stands for time, and F stands for how much fertilizer have I got. How much should I start with? $50. I have 50 milligrams I started with. What am I doing to my fertilizer? I'm halving it. That's why it's called half-life, because that's the actual B value. Now I can put a half in there or 0.5, whichever you prefer, but I'm going to put a half in there to show you that that's where the 0.5 in the previous formula came from. Then my power has to be T divided by how many days it takes to half, which is 14.3. So that's my function that I'm supposed to write. It says write the function. Then in the second question it says find the amount of phosphorus remaining after 84 days. So I could put in 84 and get the answer to the question for the second part. 84 days is the total time. 14.3 is just the time it takes to half. And that's why it's important to know that's what the X in the formula represents. Now, This is in milligrams. Can I have a decimal? All right, everybody round off 3 places, put it on your paper. We're not going to call it out because y'all can put stuff in your calculator and round. Although once in a while we might call it out just because we're talking about rounding rules, but y'all can round to 3. So in the last question I want to look at number 14, which is about carbon-14. Isn't that odd that I put those two together and didn't even know it? Just a coinky-dink. Question number 14 is about carbon-14, which is used to determine the age of an artifact in carbon dating. So when something dies, whether it's a plant, an animal, or a human, the amount of carbon in your body stops increasing. Okay? It increases as long as you're living. But once you die, it starts to decrease. The amount of carbon you have in your body halves, or in whatever artifact it happens to be, halves every 5,730 years. So it takes a long time for it to decay, which is why they use it for carbon dating. Write a function for a 24 milligram sample. All right, so since it says function, I'm going to say C of T for carbon, because it just sounds like to me that how much carbon I have would be a good variable, and it's always about time. How much carbon did I have when I started? 24. What am I doing? Well, I'm halving it. So this is always a half because that's your weight. Just like our paper problem was doubling, this is halving. And then my variable T is going to be divided by 5,730 because that's how long it takes to half one time. Now, this is also the kind of thing you could use for radioactivity. Radioactive isotopes, half every so many years. It's a different number, but it's still the same kind of concept. So now it says find the amount remaining after 30 millennia. A millennium is 1,000 years, so what's 30 millennia? 30,000, yeah, 30,000. And that's something you had to read into the question and know, because I wouldn't expected you to just know that off the top of your head. So we're going to plug that number in for our T. That I would not divide out in my head. I would just put that up there in the box, or for the 83 people, you have to put parentheses around that power. Now, can the number of milligrams again be a decimal? So we can write a 3 decimal place answer for the milligrams for this answer. I don't expect a lot left. Yes. So we've looked at quite a few formulas. So we've looked at 1 plus or minus r to the x power, or t power. X and t are kind of interchangeable. We've looked at ab to the x power, or if it's a half-life problem, t over the number of time for the x. Now we're going to start looking even more in depth into these problems that use the a times 1 plus or minus r to the t power. So we're going to look at some population problems, and then we're going to get into more banking stuff. All right, the population of a certain animal species decreases. What does that tell me my formula is going to have? Subtraction. At a rate of 3.5%. So we're going to make that 0.035, right? You have counted 80 animals in your habitat. That sounds like A. That you're studying. Write a function that models the change in population. So P of T, why did I use P? Exactly. Is going to be how much I had when I started, because again, this is A1 plus or minus R to the T power, or X power, depending on which letter you'd like to use instead. So I have to put 1 minus what? Yeah, that decimal for the 3.5, 0.035, to the power of t, because I'm just making a formula, I don't have a time yet to plug in. So if they ask you to make a function, you write function notation, instead of just saying p equals, and you leave the t in your formula so that you have a place to put it if they ask you to do a calculation. Now in question part B, it says make a graph of the function. And that could be done two ways. You could use Desmos or y equals. I have it in Desmos, so we'll just look at it in Desmos. And estimate the number of years until the population first drops below 15. So when it's equal to 15, I would think right after that it would be under 15, right? Everybody agree? So I'm looking for when is P of T equal to 15. Now, I could set this equal to the formula like this. Could I divide by the 80 like we did before and get rid of it? The only problem is then I'd have to change it to an exponential and get the decimal for this, and that takes time. That's why they told you to look at the graph, because it's a little quicker with graphing. And I have that in the calculator. So if I put that in, I have to put y equal 15 or it won't graph the 15. I probably should have put y equal on the other one too, but it graphed it without it. And so you can either use Desmos or you can use your graphing calculator and do y1, y2 and find where it crosses. So here's how much time it takes before it drops to 15, and right after that it's below 15. So when it gets to 46.986, well, what's this problem about? Years? Years. All right, it takes 46.986 years before it will get to 15. So right after that, it'll be below 15. So if it's more than that, right? More time than that? And so if you get a problem in which you don't know your time, then you can either do it in Desmos or y1, y2 on your calculator to get your time. And if they didn't give you a rate, you could do the same thing. All right. Let's look at one more world population problem. $46,896, I believe. Years. 46.986 years. I'm sorry, it wasn't thousands. It's 46 years, but it's 46.986 years. All right. So the world population can change because it can decrease because we have an epidemic comes through and a bunch of people die, or it can increase because there's more births than deaths. So in this problem, the world population in 2000 was about 6.08 billion. The annual rate of increase is 1.26%. Find the growth rate of the world population. Now let's talk about what a growth rate is. A growth rate is what your B actually represents in your formulas. So growth rate is what B is, and it's either 1 plus or minus R. So that B that we put the half or that 2 in is a growth rate. But when you're given how much it increases by, you got to calculate it. So 1 plus 0.0126 is the decimal for that percent. And so when you add that together, you get 1.0126 is my growth rate. Well, that makes sense. It was 100% and it went up 1.26%. So it should be over 100%. And that's 101.26%. Now, it didn't ask me to make it a percent, did it? It asked for the growth rate, which means to leave it in decimal form. Suppose the rate of increase continues to be that, write a model for the world population. So P of T, we got to do that function notation again because it uses the word function. And how much was the population when I started? 6.08 billion. How do I put billion in there? I don't. I just put billion, the word, on the answer when I get the answer. And then 1.0126 to the T power. That's what the growth rate is for. It just keeps you from having to write an addition problem in there. On some of your state test questions, they might ask you just to write the formula. And if you could just pick out which percentage has the right information in here because you added or subtracted correctly, you can pick it out real quick and you'll know the answer. So that's why it's important to actually see the formula sometime with that added together. All right, we're moving on to money number 25. There is a formula that you learned, I believe, in Math 1 that says the account balance is equal to the principal 1 plus R, the rate, divided by the number of times you want to compound it, NT or TN up here in the power. That formula works really well even for annual problems, because what's annual mean? What number do you think that means? 1. And if I put a 1 here and a 1 there, does that make the problem a little simpler? But instead of having to learn a separate formula for it, we just learn this one and just know that annual means 1. The other thing is once in a while they'll use the word depreciates, and we know depreciates means put a subtraction sign in the formula, right? Well, that formula usually isn't used for depreciation, so therefore, if I put a subtraction sign in here, just keep in mind, if we're at the bank, I hope my money's not depreciating, because they won't tell you it's increasing or decreasing if it's a bank problem. So if you put money in the bank, don't you want it to grow? Just remember, if it's a problem about the bank, it's got a big plus. That way we don't have to learn 5 or 6 different formulas. We can use them over and over and over. So it says, write the exponential model for each situation and find the value after 5 years. So we have to do 2 things for each of these 2 parts down here at A and B. So write an exponential model that talks about a car's depreciation here. So I guess C of T, or I could put A of T actually. A of T because it's account balance type thought. They usually do A for money. We got $12,500 is the price of the car. Since it's depreciating, that's 1 minus what? 0.09 to the T power. Why is there no N in here? Because what does annual mean again? 1. So we can just leave the N's out and do it with 1. Then it asks us to do 5 years. So you just simply plug in the 5 and get the answer. The answer to this is money. How many decimal places are we going to write? 2. Now, since it's depreciating, I assume it's going to be less than 12,500. If you get more than 12,500 or the same number back, you're not doing it right. If you get more, doesn't make sense, right? 7,000 what? Point what? 40. Everybody agree with her rounding? All right, so that's what that direction means, is to do the formula and then show that what you plugged in and what you get as an answer for plugging that in. You don't have to actually show that you wrote the 5 here unless you just want to. All right, baseball cards bought at $50, increase in value 3% each year. A of T equals what? All right, what? 1 plus, okay. 0.03 to the T power, right? It also asks us to do this one for 5 years. So you plug in 5 to figure out how much will your baseball card. This is just one card. You paid $50 for this card. It must be really special. And you're going to see how much is it worth in 5 years. $57.96. So it didn't go up a huge amount, but it did go up at least. So annually is pretty simple. There's nothing real complicated about annual. But sometimes it can be a little strange. So let's look at one more. How much did you deposit in your account to pay 6.5% interest compounded yearly? Does the word yearly and annually mean the same thing? Yes. It means once a year. So that the balance is 600. So I didn't start with 600. I want to end up with 600, which means this is A. So after 8 years of leaving it in the bank, I want to see what would I have had to put in at the beginning to get the 600 at the end. So in that case, 600 is your A. Now, did it say I had to write the formula out in function notation? No, so I'm leaving that part off. P 1 plus r to the t power, because I don't need the n's, right? Everybody agree? N's 1? I don't know p. But I know 0.065 is r and t is 8. And if you want to put the 1s in there, you can. It's not wrong to put the 1s, we just don't need them. Now here's the key. I don't need y1, y2 for this problem, although I could. Because all I need to do is divide. It says times a parentheses with p, so I would assume if I divide by that parentheses that I'll get rid of p by itself, right? If I divide by the whole big power problem, I can divide by a power problem. You don't always have to do logarithms to solve exponentials, y'all. So if I divide that out, it should give me something less than $600, telling me how much money I had to put in the bank to earn $600 in 8 years. 500 what? Or is it 500 something? It's probably not that big, is it? 400? Point what?
362.
All right. Somebody look at his and see what he did. 362 point what? Did you get 54?
Yeah.
53? It don't round up?
It does. It rounds up.
It rounds up.
Okay. All right. So the key here is, that's not a huge amount of money, but that's more than half. I have to put more than half of it in, leave it for 8 years and don't touch it just to get $600. It doesn't sound like a really good way of earning money, does it? Which is why getting money from a bank is probably not the best investment. People invest in stocks because you earn more, but it's risky. This is safe. All right, 2 more things and we'll be done. I know this takes a long time, but there's a lot to it. I'm trying to review what you're already supposed to know, and I'm also trying to show you a couple of new things in between some of that. The majority of this is Math 1. So compounded, well, what if n's a number that's not 1? Because n can be 2 for semi-annual. It can be 4 for quarterly. It can be 12 for monthly. And it can be 365 for daily. So what's the bank do on leap year to get you your interest on the 366 day? They write a special program that runs that day to get you your interest because they can't make their program do it. Because it only knows how to do it 365 days a year. So they load a program, and on February the 29th, it runs all day, and they unload it the next day to get you your interest that extra day. All right, so these are the words that we have to know that means a number for n. But we're going to use the same formula we had earlier. So if I deposit, well, I can't get my marker to work. There we go. If I put in 5,000, what is the decimal for my percent? 0.025. But now I have to put something under it because I'm not doing annual anymore. I'm doing monthly. So I have to put 12 under it because monthly there's 12 months. Then you can multiply that 12 times how many years it took to do the problem, because I did it for 10 years. Like, for example, that's how many times the bank's going to calculate your interest during the 10 years. So if they do it 12 times a year for 10 years, that's 120. That's how many times they're going to pay you interest during that time factor. You can come back and calculate that later. Let's move on. We're going to do one more in this set. Notice these numbers look the same as the last question that we just worked on this type of problem. Do they not? But I changed it to semi-annually so you can see if I do it twice a year, does that make a difference in how much I have to put in the bank? So we have $600 still. We don't know the principal. We're still doing the 0.065 like we did on the 2 problems back. Divided by semi-annually means twice a year. And we're going to use that twice a year times 8, which means they're going to calculate my interest 16 times. Now I'm going to do 600 divided by that, just like I did before. Although I might type 16 up there. Wouldn't that be a whole lot easier to type? And you should get something less, I think, than we got before.
I got 359.
359 point what? 68? That is less than we had the last time, wasn't it? Not a whole lot less, because we only do it twice a year instead of once a year. But as you increase how many times it calculates the interest, that amount keeps going down because you don't have to put as much in the bank to earn it. Now, 2 problems left. And this is really new, so very much pay attention. How many things do you think I've taught that you've never seen before today? The first and the last. The rest of it's all taught in Math 1. But it's a good thing we went over it, wasn't it? All right. Compounded continuously is a different formula. It is A equals PE to the RT power. The word continuous tells you to use E because it means they want to calculate the interest continuously over and over and over. Never stop calculating interest. For it to do that, you have to use a natural number to do it. To remember this, think of it like this. I got some greasy hair and I need to wash my hair. And I'm going to wash my hair continuously until I get my hair clean, right? I'm going to use Pert shampoo. Pert is the name of this formula. It spells the word for the shampoo, and I'm going to wash my hair continuously until I get the grease out. Maybe that'll help you remember the mnemonic. So we're going to put $5,000 in. We're going to put it at 0.025% for 10 years. So this formula is a little different because it doesn't do the 1 plus or minus or any of that. It has E in it. Now you can calculate that later. One more. Oh, do these numbers look like the 2 of the other problems we've just worked? So if A equals PE to the RT power is for continuously, then this would be the least amount of money I'd have to put in the bank to earn the 600. So A is still 600. P I still don't know. 0.065 is my rate for the 8 years that we've been talking about. Notice I don't have a number that represents anything about N anymore because we're doing it continuously, over and over and over, calculating interest. So I'm going to divide by that exponential, which is different from the solving we looked at earlier today, because to solve this exponential, I don't change it to a log because I'm not missing anything in E. I just divide by that E. That makes this drop off and gives me the least amount of money I can put in my bank account to earn it at that rate for 8 years, which is not that much less than the semi-annual answer, is it? So I've tried to show you a variety of different types of questions scattered through this packet. This is due Friday when you take your test, but it is to your advantage to do as much of it as you can tonight for homework because tomorrow we'll have graphing homework also. But if you come across one you don't know how to do, skip it and move on. But you've got some samples of everything and you have formulas for everything. That means the formulas you have to know, they don't give them to you.